Hello everybody, welcome to Build or Buy. Thanks for joining us. Hope you'll subscribe. Today we're going to be talking about NVMe RAID. I'm your host, Gil Boyd, and this is Build or Buy. The card we're going to use is this ASUS Hyper M2 X16 card. Now, there's several cards that different manufacturers have. This is one we think is probably the best bang for the buck. Now, if you need a reason to build a Threadripper, this is one of them. And that's what we're going to be using this in. This is an upgrade for our X399 second generation Threadripper. Now, ASUS makes a card, ASRock makes a card, Gigabyte theoretically makes 4 cards. One of them was a proof of concept for the Intel Optane technology. We'll probably never see it in retail. The other 3, one of them only uses 2 drives, the other 2 use 4 drives each. And of those 3 products that Gigabyte does have available, they are considered server components. So they're available, hard to find. One of them uses 4 drives on the face of the card, just like this ASUS, just like the ASRock. And one of the cards has a sandwich where you have 2 M.2 drives on each side, which is kind of interesting. So you got a sandwich plus another layer. But again, that's a server component. But to use this card, most people ask the question, will this work in my computer? The first thing you're going to have is a PCI Express 3.0 slot. A PCI Express 3.0 by 16, not only just a 16x lane, but a 16 lane slot. So you're going to need 16 lanes, and they're going to need to be bifurcated, which means you'll need to go into your BIOS if it supports it, and it will be by 4 by 4 by 4 by 4. Because remember, this does not support just M.2 SSDs. This supports 4 M.2 NVMe SSDs, only NVMe drives. Now, what would happen if you put this in an 8-lane slot? You'd see 2 drives, and you want to go 1, 2, 3, and 4. But to make use of this the way we're going to do it, this is all about NVMe RAID. So we're going to take this out of the box, and the first thing I'm going to do is get my gloves put on, because I'm going to be grounded, and we're going to use Samsung M.2 NVMe drives, and we're going to be using the 500 gig versions. So what we're going to end up with when we get through with this is a 2 terabyte NVMe RAID drive. Now, an NVMe RAID could be used one of 2 ways. One, you could use it for the operating system, which I don't think is a good idea. And the reason for that is because this is going to be using the BIOS to do the RAID, and every time the BIOS updates, you got to rebuild the RAID. That would get old. We're going to use this for a scratch drive, or as some would call it, as a media drive for rendering video, to see if we can eliminate all those bottlenecks. So with our Threadripper and with this card and with the video card, we hope this thing is just going to go zooming right through. So we're going to get this out of the box. So this is the ASUS Hyper M2 by 16 card, and we're going to have 4 of these Samsung drives that we're going to put on this card. 500 gigs, it'll give us 2 terabytes. The first thing I'm going to do is look at the card on the edge, and I'm looking to see if I can see anything. I've got a serial number, but I don't have anything like a part number. And the simplicity of this is we're going to be using this with the X399 chipset. If you use this with the X299 chipset, you can get RAID 0 without a VRock chip. But if you want the other RAID, RAID 1, RAID 5, or RAID 10, you'll have to have that VRock chip on the X299. But we're using this on the X399, so no VRock involved, no hassle. And I'll put up links to all this information. There's a specific chip if you need the VRock that you need to be aware of. I'll put a link up to it, tell you the model. Now, this is one thing I like about a box. I've got a seal. That's always been our expectation with motherboards. The new motherboards, we don't get a seal. So I'm going to break that seal. It's in an anti-static bag. Again, we don't get that on motherboards anymore either. The card has some heft to it. So we're going to get it out and examine it. On the back side, the PCB. On the front side, you've got the heat sink. And as we go around the edge examining the card, what's interesting comparing this ASUS to the ASRock card is a different beast. And the ASRock card is nice because if you wanted to put, say, 4 of these in a machine, that'd be the one to go with. But this is for 1. Because remember, on the X399, we have 2 PCI Express 3.0 by 16 slots and 2 PCI Express 3.0 by 8 slots. This is going to go in a 2nd by 16 slot, and we'll bifurcate it for each one of those NVMe drives. But I'm curious that they don't have a power tap on here, so we draw all power for these drives. So we plug this in mechanically and electrically to activate this. Now on the other end, what I do like on this end, we've got 4 LEDs for each one of the drives, so we'll see activity, we can see out of the back. We've also got a switch for the fan. Now this has the same kind of type fan that's in common with the ASRock card, which I'm not a fan of. Now there's another card I'll mention that's made by MSI. The MSI has probably got the best card if you can get your hands on one, but oh by the way, it's only available with one specific motherboard. I believe it's the MSI MEG CREATION X399. An amazing card. It looks like a smaller video card, but it's only sold with that board. Now I would hope later they would sell it by itself, but I can understand if they don't, and here's why. Based on the questions that are being asked and people that are complaining about why this doesn't work, they don't understand the technology. So to eliminate those questions, I think that's why MSI says if you're going to install one of these kind of cards, we're only going to tell you how to make it work in our system, and we're only going to include it with one motherboard. But for what we want to do, this card should do the deal. We don't need to be able to stick 4 of these in a machine. To put 4 of these type cards in, the ASRock has a set of switches in this lower quadrant, and those 4 switches allow you to identify card 1, 2, 3, and 4. And to do that, you'd have to have a motherboard that has 5 PCI Express by 16 slots, which is going to be rare, probably a workstation class motherboard with PLX chips to enable that feature. So what we're going to do is get this out, take the cover off of it, and then proceed to put our drives in it. Now, anti-static bag, let's see what else is in the box. The screws we'll need to put the drives on, 1, 2, 3, and 4, and a manual. And there is no driver for those that are wondering. Because this is the X399 chipset, we're going to use the NVMe driver supplied by AMD. So we'll get that box out of the way. Boy, those are tiny screws. I don't even think a #1 Phillips will do that. I've got my anti-static gloves on. I've got my ground strap on. So I'm ready to go to town on this. So we're going to have our jeweler's screwdrivers to get that back off. I was afraid the screws might be on tight. They are not. But you will need one of those jeweler's micro screwdrivers. A #1 Phillips would be too big. The serial number on the back of the card will match what's on the box. That's good to know. Now with the heat sink removed, we'll turn this over. And here's my beef probably with this card and the ASRock card. I'm not really fond of this little bitty fan on here. My concern about this fan is eventually that fan, not if it fails, but when it fails, what we're going to do about it. And I'm concerned about that. So trying to find that, that's going to be a bear. And we're going to have, according to the drives, 1, you'll notice the 1 down there. Let me see if I can zoom in on that a little bit. This would be drive 1. This would be drive 2. You notice the 2 right there. Drive 3 and drive 4. Now, if somebody were going to put this in an 8-lane slot, you'd see drive 1 and drive 2. So you'd want to put it in the slots accordingly. But if you're only going to use 2 of these, then I'd suggest a different card instead of this one. So we're going to put all 4 of them in. I like products that have a seal on them, so I know nobody else has messed with it. I don't like products that don't have a seal. Now if you'll notice, this card will take all 4 lengths, and these are the thermistors that identify temperature. And that's something else I also like about the ASRock card. The ASRock card not only has LEDs to show drive activity, it has a row of LEDs that will activate according to color to tell you temperature, which I think is really nice. It's a little bit more expensive card than this, but neither one of these has bifurcation built in. It depends on bifurcation on the motherboard. Now, if you want to put these in, say, something other than an X299 or X399 motherboard, then what you're going to want is a card that has the bifurcation switch built in. For example, if this says a $100 card, you're looking at a $400 card because it'd have the bifurcation switch on it. Then you could use it in just about any computer that would only have one requirement, which would be a PCI Express 3.0 slot. So there's one drive. Drive number 2. Drive number 3. Drive number 4. Now if you'll notice, this will take all the standard formats. The standard is 2280, which is 22 millimeters wide by 80 millimeters long, 2242, 2260, 2280, and 22110. So we're going to take all these little screws that came with this and go ahead and get these mounted. So in our pack of screws, 1 screw for the standoff, 1 screw to hold the drive down. We also have an anti-static mat here we're working under. We get all of our screws out. And even though this is an ASUS product, we're going to be putting this on a Gigabyte motherboard. This will be the X399 ORS Extreme, but it would also work in any other X399 motherboard. In fact, we might even try it in our next X399 build. And these are going to require a wrench. That's mighty nice of them. These anti-static gloves work pretty well. They have a little bit of a rubber tip on them, so I've got a little bit of a grip for manual dexterity. It would be nice if they would go ahead and set those for us on the 2280 position. Most all M.2 drives are 2280, but we're going to be seeing more of the other formats coming online. So now I've got to find a wrench that I can secure that with. That looks like 5/32. Let's see if that works. Nope, bigger. 3/16. Yep. Okay, so you'll need a 3/16 wrench to secure all 4 of those. And I just did a finger tighten on that. Okay, let's get our drives in. 4 sticks of chewing gum. And these are the 970 Evo. And if you'll notice, just one notch. Pop that in. Drive 1, drive 2, drive 3. Now you have to remember, every time the BIOS updates, you have to rebuild the RAID, so choose your RAID wisely. Okay, we got all 4 drives in. Now all we need to do is put the screws to them. Where's a magnetic screwdriver when you need one? Drive 1, down it goes. Drive 2, down it goes. Drive 3, down it goes. Drive 4, down it goes. And there we have all 4 drives, from the bottom to the top. Number 1, number 2, number 3, number 4. Before we put the cover on this heatsink, if you'll notice, each one of these has thermal tape. So we need to peel this cover off to expose this to put on top of these to get a bond. And that will help for cooling. 1, 2, 3, and 4. Now remember the orientation, the fan right over here. So we're going to turn that around. That's a nice heatsink. And place that right on top. Turn it over, make sure our holes are lined up, and reverse the order. Put our 4 screws back in. These screws look like they're coated with Loctite. Just enough Loctite. This is blue Loctite, so it should help them to stay without working their way out. But before I tighten any one of the screws, I'll get all 4 of them started, just to make sure. You feel a little bit of an indentation when you set them in, so you know they're right. Number 1, the order doesn't matter how you put these down. I'm just crisscrossing, kind of like when you do lug nuts. 4 drives mounted, and that's now ready to be installed with 4 drives mounted. Hyper M.2 by 16 card. You can see the back of it. Turn it around. Heat sink on that edge. Nothing exposed to get to. And on this edge, the outer edge, we're going to have 4 LEDs that will show the lights, drive activity on each drive, and then 1 switch for the fan. And by default, the fan is on. And then on the top, nothing. On the ASRock, there's a power tap. We are ready now to install this in the computer. We're ready for the next step. Now we're going to power the computer down, get the card installed. Computer shut down. Turn the power supply off. Unplug it. This will be PCI Express slot by 16 number 2. That's an 8-lane slot. We have a Thunderbolt card in, and there's another 8-lane slot. So that's the slot we want to go for. So we'll eyeball. Okay, card's locked in. You have to have a 16-lane slot for this to work. Now if you'll notice, we have 1 slot left. Now this is resource allocation. 1 PCI Express 3.0 by 16 slot for the video card. The second PCI Express 3.0 by 16 slot for the NVMe RAID card. At least that's how we're going to use it. We have a Thunderbolt 3 card in here, which is the Titan Ridge. And we have a slot for something else, whatever we may choose. And we've only got 1 NVMe on the motherboard. The other 2 NVMe slots we're not going to use. Thumbs up for the Hyper M.2 by 16 card by ASUS. Okay folks, Now we got the hardware part done. Card works. The other way to look at this is one of those NVMe quad cards. And this is the one we think that's probably the best bang for the buck. Step 1, hardware. We've got that done. Step 2, now we're going to go after the BIOS. Now the BIOS can go one of two ways. One, we can go to the BIOS, bifurcate the slot, then we can go into Windows and we can set that up for a software RAID. Or two, the path we're going to go after is the hardware RAID. BIOS, stick with us. First thing we need to do is reboot and get to the BIOS screen. Okay, first step, now that we're in the BIOS, number 1, we're going to go to chipset. We're going to bifurcate the slot. While we're here, go ahead under NVMe RAID and enable that. Reboot, come back, go to BIOS, CSM support, disable. Reboot, come back, go to peripherals. If it's between AMD and Intel, that means you've also turned on SSD RAID as well as the NVMe RAID. We're only going after NVMe RAID, and there's two types of NVMe RAIDs, hardware and software. We're going to do hardware. And of hardware, the default expectation, never assume anything, is that you're going to do an NVMe bootable array. We are not. What we're going to show once we get into Windows is we're going to do a RAID array on another drive that's not bootable. And that's kind of tricky because the expectation from Gigabyte, AMD, and Intel is all that's going to be a boot array. We're not doing that. This is for a media drive. So stick with us. So we're going to go into RAID Expert. Now we can look at controller management. What we want to do is go under array management. Now this is the first part that probably snags most people. The reason being because all the drives when we're installed, remember we've got 5 drives. We have the boot drive, and we have the other 4 drives, 5 drives. 4 drives on the card, 1 drive boot, 5 drives. Remember that. So we'll go into array management, and if you'll notice, what you need to do is create an array, but you can't create an array because all the arrays are already named. You have to delete array even though you haven't created one. So we're going to go in and we'll look at delete array, and if you'll notice, there are 5 drives. Now we've already set 2 drives, so I'm going to show you the difference, and the reason for this, it's important to know which drive is on which controller and what the drive number is. Now array 1, array 2, array 3, array 4, and array 5. If you'll notice, that's a 1 terabyte drive, array 5. That's the boot drive. It's disabled. If you'll notice, array 4, RAID 0, 999. That is 2 drives put in a RAID array. And then we have a 0 kilobyte, which is a part of that RAID 0. We don't want to touch that. And the other 2 that we could manage to mess with are these 2. So if we were to delete these 2 drives to put them in a RAID array, or if we wanted to put all 4 drives in the RAID array, which is what it should be, but I'm showing you what happens with 2 drives in RAID and 2 drives not in RAID. So what we would want to do, press enter and enable, and once we enable, we could then delete an array. But I'm not going to do that right now, so I'm going to escape out of this, and I'm going to show you under manage array properties. But remember, you have to delete an array before you can create an array. To me, that's just counterintuitive, but that's the first gotcha. There's 2 more gotchas that you're going to want to know about. So we're going to go manage array properties, and we're going to select the array. And if you'll notice, 500, 500, 0, 99. These 2 are associated, and that last one is the boot drive. We don't want to mess with it. Now we can go down here and look at associated physical disks, and for that RAID array, it shows the physical disk, and it says disabled. I'm going to go and select the RAID array that already exists, RAID 0. Now bear with me while I go through these details, because it's really important to know which drive is where if you want to use 2 drives or if you want to use all 4. My suggestion is all 4, but for this, let's say, presentation, for this experiment in technology, we're doing 2 of the drives so we can compare and know the controllers, because the drives are numbered in the BIOS from top to bottom, whereas once we get to Windows, the drives appear to be numbered from bottom to top, and they're not sequential. So this is important to know which drive is which. Stay with us. Now, in the RAID 0 array, we're going to select that. We're going to view the associated disks, and if you'll notice, the 2 drives, 010 and 110, on the controller, those 2 drives are drive 1 and drive 2. We still have drive 3 and drive 4. Now, 1 and 2 are in a RAID array. And I'm going to go into Windows and show you what the difference in what the driver looks like. That's why I've done this way. These other two drives we're going to point out are not in a RAID array. To put all four of these in a RAID array, I have to get rid of these two and put them all four in. But I wanted to show you what it looks like, what two would be in the array and what two would be out of the array, so you know the numbers 1, 2, 3, and 4. So in this first RAID array, it's a 0, 1, 0, and 1, 1, 0. So I'm going to escape. Let's go back up and select a different drive, and we're going to look at we're going to look at array 1 and array 2. Now array 1 is drive 210. That's the first drive. That would be actually drive number 3 on the card. 210. We'll select number 2, associated disks, and that's drive 310. So 210, 310. Now let's look at the RAID 0. Array number 4, we set up RAID 0. We're only looking at capacity. Now, if someone were to say for conversation's sake, why would I bother with this? Okay, we've got 4 NVMe drives on this card. Each one is a 500 gig drive, Samsung 970s. What if we were to say, okay, well, 1 2 terabyte NVMe drive for a media drive for rendering? Makes a lot of sense. Okay, for most people, that's a lot of space for rendering, but what if you wanted to do a bigger drive? How big of a drive can you get? 2 terabytes. On this card, you can put 4 drives in that are 2 terabytes each. 2, 4, 6, 8. That's 8 terabytes. That's a lot of space in RAID 0. And there's no redundancy, no backup. It's just strictly for speed. And that too is kind of an interesting topic, but we'll get to that. Let's just stay with this. Okay, now we know what the drives are and we know where the drives are. And once you create an array, then we can reboot and go right into Windows. But remember to reboot each one of these steps so that the menu will come up for RAID Expert. Now the next thing is we're going to go into Windows. And that pretty much covers step 2. So now we're going to reboot, get back into Windows. We're going to do step 3. Step 3 is kind of a two-part because what we need to do is from Device Manager. Now I'm going to show you some instructions on what you have to do with those drivers and how to get this thing to be recognized. Because remember, this is a standard that's been around since Windows 95. Windows sees the controller, it sees what's on the controller. We change the way the Windows sees the controller and we'll change what it sees on the controller. From here now we need to go to Device Manager. So we'll right click on Start, Device Manager. And two things we can do in here. We can check the drives to verify where they're at. But more importantly, remembering the sequence of the drives, we're going to go to Storage Controllers. And if you'll notice, we've got 2 bottom device, 2 RAID controllers, which are store port, and we have 3 NVMe controllers. Now, with 5 drives, there would be 1, 2, 3, 4, 5, but we've already taken 2 of the drives and put them in the RAID. So what's important is we do not want to touch the boot drive. So I'm going to look at the first controller and I see PCI bus 65. I'm going to cancel that and go to the second controller and I got PCI bus 17. I'm going to go to the third controller and this is PCI bus 18. Okay, those 2 drives, 17 and 18, are actually drive number 3 and 4. Those are the 2 drives that if we were doing them in the RAID array that we would put all 4 of them because they have sequential numbers together. The one we don't want to touch is this drive, bus number 65. That's the boot drive. I know that. So what we have to do is go into these other 2 drives and change the drive controller. Once the drive controller changes, these RAID drivers install. It's a 3-step process. You don't have to reboot, but you will have to tell the Device Manager to enumerate. In other words, scan for hardware changes. I'm going to show you a link that tells you how to do this. It's real simple and straightforward. And I stumbled into this quite by accident. Now, this is on the Gigabyte forum, and somebody was having difficulty trying to get things working for him for RAID. And the link I've got, and I'll put the link up on Build or Buy, is from Ketma. And he said, this is what I did to get the array working in Windows 10, assuming you have built the array in the BIOS and you are in Windows. Download the drivers, which is what you need to do, and you'll update each Samsung NVMe controller with the RC bottom. rcbottom.inf. This will show as an AMD RAID bottom device. 2 other unknown devices will be listed. Update those entries from the same location with the rcraid.inf. This will update these to show the AMD RAID controller store port. Now, he says reboot. You do not have to reboot. All you have to do is tell it to enumerate the devices or do a scan for hardware changes. It means the same thing. Another unknown device will be listed. Update again from this same location and use the RC CFG. This will then update the device to the AMD RAID array by SCSI disk device. And then finally in Device Manager, System Devices, there will be another device listed, and you will update with that also with the RC CFG INF. And this will update to show the AMD RAID config device. These are the instructions we followed. It works. It's bulletproof. We had no blue screens. And we've got to get the driver installed for the RAID controller. That's the first part. It's kind of a gotcha because this has to be done manually, and we're going to show you. We first have to download the driver. So we'll go to AMD's website, do a search for the X399 drivers. You'll want to make sure you've got the latest chipset drivers, but specifically what we want are the RAID drivers. Now there's the RAID installer and the RAID driver. All we want is the RAID driver. Download that right now. This is dated 10/26/2018, and this is 92087. Download that file, then I'll go find it on the hard drive, and that's the driver. I've got a copy of it with my other drivers, and what we want to do now is unzip that driver, the AMD RAID driver, which I've already done. Here's the RAID driver. I'm going to look inside AMD RAID. Now what we're going to do is we're going to point our configuration. If you'll notice right there it says drivers, RAID NVMe, and there's the RAID bottom, the RAID CFG, and the RAID driver. We're going to point from Device Manager the existing driver to change to these drivers, and we're going to follow the directions from this website. The two drives that we want to change the controller on are 17 and 18. So what we would do, starting with 17, following his advice, we'd go to driver. We would say update the driver. We're going to browse the computer, and I've already done this, so it's going to look in that folder. And the first one we want to go to, let's tab back over, is the RC bottom INF. So what we'll do is browse, go to the location wherever you put that stuff, and if you'll notice it's in that folder, rcbottom.inf, then say OK. Click next and it'll do its thing. And if you'll follow these instructions, RC bottom, and you don't need to reboot, you just need to tell Device Manager, click in Device Manager, click on Action, say Scan for hardware changes. That'll have the same effect as rebooting, so that way you can stay in Windows and keep working. But you want to update those controllers, and once you've done that, then you'll have a RAID array. But I wanted to show you one that's working so you know that it works. I'm not actually going through the process, but I'm telling you how to do it. That we have two drives, the C drive, and I've given this a name of hardware RAID. It's two drives. Now, for you that are creating this from the start, what you'll have to do instead of going straight to this is you're going to have to go to disk management because you're going to have to format the partition. So I'm going to go to disk management. I'll go back down here to start menu, right click, disk management. Now when this pops up, because I have two drives in this machine that I have not configured, it's trying to configure them for me. Those two drives are sitting there as is. They could be used as is, but I will change them to part of that RAID array. But right now I'm in the process of still testing. So if you'll notice, I've given this a name. I've got the C drive, which I do not want to touch, and I have the RAID volume, which is two drives, volume 3. So we're going to go down here and we're going to look at these drives. First you'll see a disk 0 and a disk 1. Those are the two drives that are still sitting waiting to have something done to them, to be put in the RAID array or used as is. I could format them. Windows keeps wanting to format them for me. I don't want to do that now because I'm trying to show you what you're looking at. And the other two drives that are in the RAID array, by changing the drivers the way I showed you, right there it is, that's a volume. And that hardware RAID volume is volume E. I can change the drive letter, but once this is done in Windows, in disk management, now I can go back to the Windows Explorer and I can click on this PC and I can see my hardware RAID volume, which is 930 gigs. That's two 500 gig drives put together. Kind of cool when you think about it. Now this is all about the technology. We could have done a software RAID, but we've done hardware RAID, but we've only got two drives in the hardware RAID. I wanted to do this for the experimentation so I could show you the difference in what the controllers look like. This is still set as a hardware RAID with two drives, but the other two drives, drive 3 and 4, are still sitting out there, and the boot drive, which is an NVMe drive, has not been touched. But to make this work, you have to do it manually. If you run the automatic install, it'll all day long keep telling you it's going to fail, and it will fail because it has an expectation. All three of the vendors, AMD, Gigabyte and Intel expect you to use an NVMe boot drive in the RAID. We don't want to do that. We're putting our RAID array for the media drive. That's what we've shown you. Now the next question comes up, how fast is my RAID array? And that's something I want to leave you some final thoughts. I've run a couple of tests. I'll show you some information. In fact, I'll run the test live and you be the judge. I've downloaded a tool from Blackmagic, and for those of you who want to try it, the tool is free. You can go to Blackmagic. In fact, let's just go through that. We're going to go to Blackmagic. We're going to click on support. We are going to go to capture and playback, and we are going to download desktop video. Click on Windows, desktop video. All this stuff comes up. They want you to register for the product, and if you notice here in the bottom left-hand corner, download only. So we're just going to download it, and we're downloading Blackmagic desktop video. We'll download it. We'll go to where we keep our downloads, because I've done this some time ago, and we're going to go to the downloads, which would be applications, and under Blackmagic, we have installed the Blackmagic desktop video. Now, once we've downloaded and installed Blackmagic desktop video, and you'll need to reboot when it's finished, we're going to go to the B's, Blackmagic. Now, what we're looking for is the speed test. So we're going to run the Blackmagic disk speed test. Don't worry about desktop video setup, live key. If you have a Blackmagic product, those other things will work. If you don't, they won't. But this will. The Blackmagic speed test. So we're going to go up here to this button in the center, click on that, and we're going to select a target drive. And we're going to choose this PC, and then we're going to choose where that RAID volume is at. And then we're going to say select folder, and now we can click on start the test. So remember, we have 2 NVMe drives in RAID. Let's see what we get for results. For those of you that want to do 4K, this is a good option. For those of you that are wondering, is hardware RAID better than software RAID? That's an interesting question. I got another test we're going to show you after this one. But as you can see, if you want to work with 4K, this will work all the way down to 4K 21p 60. 4K 60. That's a lot of video. Now, you can still do 4K on a NVMe drive by itself, but I'm just saying, if you want to run the numbers. So I'm going to stop the test by clicking start, and at this point I can click the button again. I can say save a screenshot. And disk speed test, I'll put that under, let's see, public documents. Or I might put that under, okay, that's disk speed test. Now I'm going to show you the results of our disk speed test from Blackmagic. Now this is 2 drives in a hardware RAID. I'll zoom in on that. And the dials don't tell so much because they're in a total state of flux. But as we look at what it can run, we get an idea of the reads and writes. What's curious, I also ran this on a software RAID. That was part of my experiment. I did a software RAID and then I did a hardware RAID. And I ran this test again. We've always said hardware can do a better job of anything software can do. With that said, software is doing a pretty good job and comes pretty close. So those of you that want to do a software RAID, you gain a little bit with the hardware RAID, but not as much as I expected. Got another test we'll run. And for that tool, we're going to download ASSD Benchmark from TechSpot. If you've never been to TechSpot, ASSD Benchmark. So ASSD Benchmark, we're going to run this, run it live, and I'll show you the results once we finish. And if you'll notice, I'm going to zoom in on this because it also shows what driver is being used, which is really important. It's running it by default on the 1 terabyte drive. That's the store NVMe drive. And we're doing this on the C drive, the boot drive. And when it's finished, we'll go run it on the other drive, the RAID drive. You know, it's interesting technology what we're able to do. I like what ASUS has done with this card. I like what AMD has done with the chipset. I like what Gigabyte has done with the motherboard. They're working well together. Some people have had difficulty with the PCI slots running at the correct speed with their video card, which is a process of elimination, a variety of issues. But right now, as we test and we look at this, I think everything looks pretty good. And once this finishes, sequential read and sequential write, 2949 and 2298. So we'll run it over on the other drive. Do the same thing again, see what we get. And if you'll notice, even though we're not finished, look at that sequential read and write. 5141 and 4801. Pretty impressive. And again, if you'll notice up here, the AMD RAID Array 4, that's the 2 drives in RAID. Remember, we have 4, and that shows it's using the RC RAID driver. Now, the reason we don't want to do a boot drive in RAID, because guess what happens? You've got to back everything up, and you got to recreate the RAID. And I don't know about you, but with all these applications with their licensing codes and all that, phew, I don't want that on the boot drive. I'm okay with one NVMe drive, a 1 2 terabyte or a 1 1 terabyte. Either way, I'm okay with that. But for a render drive, I don't mind it getting destroyed and getting rebuilt when I have to rebuild the BIOS or put in a new BIOS. So that was one of the reasons for this card, so we could put 4 drives on. Hardware is solid. Everything that needs to happen in the BIOS works as long as you know what you're doing. The first gotcha was you have to delete an array before you can create an array, which I think that's confusing. And then the third step when you get into Windows is you got to go through and figure out which drive is on which controller, update that controller driver, enumerate Windows or tell it to rescan, and 1 2 3 4, then your RAID appears. Then you go into the Windows Disk Management, format it, and then you can go into Windows Explorer, and voila, you got a drive. You can test, which is what we're doing, use it for rendering, which is what we're going to do, and so far it works. Got one more thing I want to show you in the testing. So now the test finished out on ASUS SSD benchmark, and we've got 5141 on the sequential read and 4801 on the sequential write, which is kind of impressive when you consider that's only 2 drives. Can you imagine what's going to happen when we have 4 drives in there? Wow. But I'm just saying, I've taken the 2 images and put them together so you can see, and I'm trying to see if I can get this zoomed where it'll show just right. Anyway, the image on the left is for the Samsung boot drive using the store NVMe driver. That's a single drive. You can see the results. And on the right, we have the 2 drives in a RAID array, and you can see the difference in the numbers. I'll move this over where I think it matters the most so you can kind of get a handle on what that looks like. Pretty interesting stuff. And the hardware rate is only a little bit faster, not a whole lot faster. So that's taken technology as far as we can. This is the ASUS Hyper M.2 by 16 card. Some refer to it as a quad NVMe card. I think it's worth the money. Take a look at it. Now, if you got a machine that can bifurcate the slot, that'll take a 16-lane slot and bifurcate it where you get 4 by 4 by 4 by 4, like we showed in the BIOS, then this will work in your machine. If your BIOS will not let you do that, then you have to have a different card. There are 2. I'll put a link up to those other 2 cards. One company makes both cards. One's bootable, one's not bootable. And this card could be bootable, but we didn't want to use it that way. We're using this for the RAID array in RAID 0 so that we can have a media drive, a fast media drive. Chain is only as strong as the weakest link. We wanted to eliminate all the bottlenecks. If you need a card that this will not support, but you want this capability, then you got to have a card that has the bifurcation switch built into it. Now, for conversation's sake, say this card's $100. The card with the switch built on it is $400, whether you get the bootable version or the non-bootable version. I believe High Point is the one that makes those 2 cards, and I'll put a link up to those 2. There are some other cards. As I said in the beginning, I'd like to get my hands on the one that MSI has. I think it looks like the best one of all of them. But after going through this card and after reading some of the concerns people have had trying to get this thing working, I have a pretty good idea now and understanding why I don't think MSI is going to sell that card by itself. This is an interesting card. We may try the ASRock card later, depends what kind of feedback we get on this. We currently have this card, and the testing we've shown you is in the Gigabyte X399 Aorus Extreme. Our next build is going to be with the Gigabyte X399 Designator EX. That should be an interesting build. So thanks for staying with us. I hope you enjoyed this. I appreciate everybody subscribing. We'll look forward to seeing you in the next video. Have a great day. Thanks for joining us. One final thought in Windows, I want to show you one last thing. If you want to install the RAID Expert software, it does a silent installation, and if you keep doing it the way they show it, it'll never work. So I'm going to show you how to drill down and find it so it'll install. Not that you need it, because there's only one thing you're going to be able to do. You could manage the whole RAID array, but it'll keep telling you about the other drives if they're not in RAID or what's going on. And if you don't need that feature, it's kind of annoying. So let me show you. Okay, there's one last step we're going to go through, and we're going to take a look at the driver. If you want to install the RAID application run within Windows, so you can also have the RAID Expert help file, don't execute RAID setup. I've shown you how to go into Packages, Drivers, and instead of Drivers to install the application, we'll go to Apps. We'll go to RAID Expert 2 Built-In. And from there you can install RAID Expert with setup, and that'll get you going. The default configuration for RAID is a silent, and if it doesn't see what it's looking for, it won't install. Now once it's installed on your desktop, you'll have 2 icons, RAID Expert Help and RAID Expert the application. Now from what I can ascertain, you can do pretty much everything you want within the BIOS. But from this location with RAID Expert, you have to first create it, access to the application, you have to put in account name and password. It'll start with the default. I've gone through the default, so all I have to do is put in my username and password. Now once I'm in the RAID array, I can see the RAID for a drive, and I can see the 2 drives in that RAID array. It shows the capacity, disk 01 and disk 11, and I can see the other drives that are legacy that need to be removed, that are offline. And if you'll notice, it goes through the configuration. But that E drive is RAID 0, and there it is. The only thing I could do was create a name, and I called it render drive for the array. That I cannot do in the BIOS. That I have to have the application. But as near as I can tell, that's the only thing I have to do from here. So there's no real need to install it, but that's how you do install it. It works from the web browser, which is kind of curious. But once you do, it's going to tell you every time you boot. If you have any drives that have gone bad, it'll pop up and tell you. And if sound's turned on, it'll tell you too. So once I delete those other RAID arrays that don't exist, it'll stop telling me about problems that don't exist. So that pretty much covers it. 1, we've shown you how to install the hardware. 2, we've shown you the settings for the BIOS. And 3, and I guess really number 2, there was kind of that quirk where you have to delete an array before you can create an array. What's with that? But anyway, that's the one quirk you have in the BIOS once you get into the RAID program. Then once you get into Windows, you've got to set the drivers. And if you go through that process 1, 2, 3 from the device menu, you'll get the drivers installed. And then the last step, if you want that application running in Windows, do what we showed you. Otherwise, if you do the default, it's looking for the boot drive. We don't have the boot drive set in the RAID, and it won't install. It'll go through that loop and never install. Drill down, do that, you'll be in business. So that's the 1, 2, 3 of getting the ASUS M.2 by 16 card running. I hope this will help you. Thanks for watching. We'll see you in the next video for Build or Buy. Thanks for subscribing. We're good. That's a wrap.